Today in Algebra 2, we are going to look at the second day of section 2.2, where we're talking about standard form of a quadratic. As a warm-up today, we want to go back to yesterday and do an example of an application problem. So yesterday in the notes, we didn't do any real-world applications, but we're going to use this as a connection to what we did. So it says the graph of a function f of x equals negative 10x squared plus 700x minus 6,000 shows the profit a company earns for selling headphones at different prices. What is the maximum profit the company can expect to earn? So the reason this connects to what we did yesterday is we're talking about the maximum of a parabola. So if we look at this graph over here, we can see that the maximum point is this very top point, which means that we're finding the vertex. Now we also need to understand in real-world problems what the x and y represent. So we can see that selling price is the x value. So for the maximum, this would be the selling price of the max. And then we can see that the y is the profit. So that's the max profit. The reason that's important to understand is this question asks for the maximum profit. So what that means, if we're thinking about it as a vertex of hk, we're looking for the k value of the vertex. So go ahead and pause the video. Using this function, really what I'm asking you to do is, can you find k for the vertex? Okay, so hopefully you remembered that you should have found h first. In order to do that, we need the a, which was negative 10, and the b, which was 700. It's the opposite of b, so negative 700 over 2 times a. Gives me negative 700 divided by negative 20, and when I did that, I got 35. So that's what the h value would be, but again, we care about that k. Yesterday we learned to find the k. You take the h and you put it in as the input in the original function. So negative 10 times 35 squared plus 700 times 35 minus 6,000. And again, this is where it's helpful if you have a nice calculator because you can type all that in one shot. And if you did, you should have gotten $6,250 is the max profit. Okay, so that's a bit of review from yesterday, but an extension of it, I guess, because now we looked at it in a real world problem. So anytime you're asked about something about the maximum or minimum point of a quadratic, even if it's in a real world, it's talking about one component of the vertex. Okay. So now that we did the warm-up together, kind of, I want you to now try this one on your own. Okay, so I want you to read it, understand the context of the situation, and then see what you come up with for your work. So pause the video and go ahead and do that. Okay, so hopefully when you read this problem, you read a water balloon was thrown from a window. The height of the water balloon over time can be modeled by the function y equals negative 16x squared plus 160x plus 50. Wants to know what the maximum height is of the water balloon after it was thrown. So once again, when we looked at our x and y value, the x of that maximum point, which is the vertex, the x is the time it takes to reach its maximum, and the y value is the max height. So once again, you were looking for that k component of the vertex. Should have seen that a is negative 16, b is 160. When you found h using negative b over 2a, you found h is 5. And finally, to find that k, you put that 5 back into the function. And you should have come up with 450 feet is the maximum height. Okay, so these problems are all well and good using what we learned yesterday, a real-world application where they give us the function or the equation that represents the parabola or quadratic. The problem is sometimes we are not given that information. So today we're going to learn how to take information and come up with a quadratic function using our calculator. This is called finding or using the quadratic regression. So here we can see that Esteban is training for the discus throw. His coach records the horizontal distance and height of one of Esteban's discus throws. The graph shows the horizontal distance the discus traveled in meters and the height of the discus in meters. What will be the height of the discus when it has traveled 15 meters? Okay, so if they had given me the function x is the distance in meters, so really all I would have to do is substitute this in for x. I would find f of 15 and figure it out. It'd be a nice, easy problem. Having said that, it doesn't give me a function. It just gives me all of these points. Now, this is an x-y coordinate pair. If you wanted to, you could, in theory, put this in a table. You could make an xy table. The x is 1, the output is 1.75. When x is 2, it's 2.71. X is 3, it's 3.52. And the reason I say that is because it doesn't matter to me which way I'm showing the points, whether it's ordered pairs, whether it's a horizontal table like this. Sometimes it'll be a vertical table. So 1, 1.75, 2, 2.71, 3, 3.52, so on and so forth. No matter which way you're given that information, we can do what's called finding the quadratic regression on our TI-84. The quadratic regression gives us the function. It gives the quadratic function for the scenario. Okay, so I want you to pause the video real quick and get these 7 steps down, or after I go through the problem on the calculator, you could pause it after and put that down. But it is important because I am going to have to leave this slideshow. All the writing on the screen right now will go away when I come back to it because I do want to open up my calculator. But what it says is first we're going to go to Stat, Edit, and then enter our x and y values under List 1 and List 2. And that's where, again, either I'll take the x's from here or I would write them in a table. After I have all my data in, I go Stat, Calc, and pick number 5 for quadratic regression. So let's exit this and look at what we mean. So if I go to my calculator, okay, so if you're in my class, remember that I did put a link for the TI-84 online calculator right under here. You'll want to ask your teacher where you can get to this one if you want it. It is the MCA practice site, so under guest, you just hit start the test. We're not taking that test, we're just using the calculator. So up here is the TI-84 button. Okay, so remembering from the last list, we said we were going to hit Stat, and then we're going to go Edit. So just Stat, Enter, and you can see that it shows me L1 and L2. L1 is going to be all of my x values. Oh dear, I can't see it on my paper. So now I was able to write down my values to see them big enough. So here we go. So my x's go from 1 to 10. So under L1, I'll hit 1, Enter. So I had to go 1, Enter, 2, Enter, okay, 3, all the way up to 10. Make sure after the last one you hit Enter so it reads it. Then you can do an arrow key to the right, and then L2 is the y values. So I'm going to enter those. 1.75, Enter. 2.71, Enter. 3.52, 4.28, 5.45, 6.12, 6.79, 7.34, 7.99, 8.55. Again, make sure after you enter your last piece of data, you hit Enter. That's one of the most common mistakes. People say they get an error on their calculator. It's because they forgot to hit Enter after that last one. Otherwise, it doesn't read a y value for 0.10. Okay, so now that we have all of the data entered, again, my x's are under L1, my y's under L2. We go back to that Stat button, and now we have to go over to Calc because we want to calculate something. And again, we want the quadratic regression. So I hit 5, Enter. Now here, it's just verifying that you want to take your x's from list 1, which we did, my y's from list 2, which we did. So I hit Enter, Enter, frequency list, this, and then calculate, Enter. So just a bunch of enters until you see this. Now you will notice that it gives you the function or the equation as y equals ax squared plus bx plus c. and then it tells you the values of a, b, and c. So when you go to write your function, you're going to have to substitute this for the a, this for the b, and this for the c. So you do have to piece it together a little bit on your own. But now I'm going to go back to our PowerPoint. You're going to have to bear with me while I scroll to where we're at. Okay, and so now I would write out what I saw. So it was f of x equals, again, the a value. If I round to 3 decimal places, which is thousandths, I get negative 0.027. Attach it to an x squared, plus 1.058x plus 0.672. Okay, so again, Pearson will do a good job of telling you what to round to. If it says thousandths, go to the 3 places. And now I can go back to the question. Again, it wants to know what will the height of the ball or the discus be after 15 meters, which means they're giving me an input of 15. I type that in. Oh, I'm supposed to put 15 in for that. And again, I would type all of this into my calculator in one shot, and I got 10.467 meters, but this is where I would for sure read Pearson. If it said round to the nearest tenth, I would put 10.5 meters. Again, if it asked for to the nearest hundredth, I would do here, and then nearest thousandth would be here. When I'm writing my regression, I usually try to keep about 3 decimal places, because the more decimal places I keep, the more accurate my answer will be. Okay, last but not least, again, make sure you pause to get this written in your notes. It's important you know those steps if you're going to be using an 84, because now I'm going to have you practice one on your own. Okay, so here it says you try, find the quadratic regression on your own. We will solve the rest together. So it says a fan threw a souvenir football into the air from the top of the bleachers toward the bottom of the bleachers. The table shows the height of the football in feet above the ground at various times in seconds. If the football was not touched by anyone on its way to the ground, how long did it take to reach the ground? So the how long it takes to reach the ground will be a new concept. But in order to do anything with this, we have to find a quadratic function for it. So I want you to take this table, plug it into your calculator, and get your quadratic regression following the steps that we just did. And when you come back, I'm going to go to my calculator screen again, show you how I did it as a review, and then we'll finish this problem together, remembering that it says how long does it take to hit the ground. Okay, so hopefully the regression that you found was f of x equals negative 16x squared plus 12x plus 10. Okay, so that's the regression you should have found by following those steps. At the end of the video, I'll go in and show you how you get that. But in the meantime, for those of you who got that right, we want to talk about how we would figure out how long it takes for the football to reach the ground. Remember, that would be when the height equals 0. And again, you might say, so when he throws it, if I just draw a graph of this, at times 0, it's 10. So the ball comes up like this. We're basically looking for this point. Okay? That point in your calculator is called the 0 of the graph. So I'm going to teach you how we find a 0 using our graphing calculator. Really, we're solving this. When does 0 equal negative 16x squared plus 12x plus 10? Now, in theory, there's 2 zeros, but one of them happens back here, which is before the ball is thrown, so we don't care about that one. We want to find this point on the graph. All right, so let me go back to my calculator. PowerPoint now. So I'm going to go to y equals, and I'm going to graph what we just came up with. So negative 16x squared plus 12x plus 10. I would go to graph. Let's see. So I got to go back to y equals. I must have made a mistake. Oh, yep. So I did that thing where when I'm typing it on my calculator or on my computer, I hit the x instead of the x on the calculator. X squared. So let's try again. Plus 12x. That's why it showed the arrow instead of the x. Plus 10. But you can see my calculator gave me an error, so I just go back and I check it out. Oh, Now let's check it again. What's going on here? Negative 16x squared plus 12x plus 10. Let's check our window. Zoom is good. Y equals, oh, let's go down. Let's make sure it reads it. Oh, you know what? Now that I think about it, I have to hit this negative sign. So I'm going to clear this. Okay, so again, if you're typing on a computer, I used the negative on my keyboard. It didn't read it. So it's a negative 16x squared plus 12x plus 10. Let's try that and hope it works. Okay. So now a quick side note, I apologize for making you sit through those couple of little errors that I made. I actually thought about starting that part over of this video, but I actually thought it was important for you guys to see that even I as a teacher using this TI-84 a little bit more often, if I was on my handheld, I wouldn't have made those mistakes, but it's because I'm typing on the keyboard. And I just want you to see that if you get errors, sometimes it just takes some time to problem solve it, okay? So I didn't know what I was doing wrong. I had to go back in 2 times. I made 2 mistakes when I typed on my keyboard instead of picking it from the buttons on the calculator. So that's again why I prefer a handheld, but if you are using the online calculator, the X button and negatives, so this negative have to come from here. You can't push those on your keyboard. Okay, now back to what we actually wanted to learn. So this is the picture of the quadratic we said. This point right here where the graph crosses the x-axis, that's the point I care about. And we said that's called a 0. So if I go into that calculate button where we found points of intersection as well, I go second calculate, we can see that another option, so we've already used intersection here, but another option is to find the 0. So I'm going to do that and hit enter. But this is a little bit different. Before it was, is it on the first graph, second curve, or first curve, second curve, guess. Now it's going to say left bound. Left bound means that I need the cursor, and I'm going to go to the right a little bit. It's saying I want this cursor to the left of this point. So if I drew an imaginary vertical line through the point, it has to be somewhere to the left of it, which it is right now. So is it on the left? Yes. So I hit enter. Now it says right bound, which means, again, if I have a vertical line through that point, it needs to be to the right of it, which means I have to jump somewhere down here. So now it's to the right of it. Yes. So I hit enter. Do I want it to guess? Yes. And you can see these tiny 2 little vertical lines here with the arrows. They're saying, is that 0 that you want? Somewhere in between, and it is. So enter, and it now tells me that that 0 is the point 1.25, 0. So the answer to the question is that it takes 1.25 seconds for the balloon to, or for the football, sorry, to land in this case, because that's when it hits the ground when the time is 0. All right. That's all I've got for day 2 of section 2.2. Go ahead into Pearson and find that assignment and work on that. Thanks.